In one of the earlier videos, we talked about the distance traveling a parabola, a ball going down a parabolic shape versus a straight line, and which one gets there first. The one traveling along the parabola, even though it's a longer distance. This is what I'm going to talk about now. Is we're going to use geometric series to make an argument with Zeno's what's called Zeno's bisection paradox. What is that? That's the question. All right, if I'm a certain distance to the wall, if I go halfway from me to the wall, and then I go half of that distance and half of that distance, will I ever get to the wall? Well, the answer to that we can argue using the same ideas we talked about before. Well, let's take a look at this. All right, let's say this is 1 unit, 1 mile, 1 meter, whatever. All right. So when we travel along this, what are we doing? The first step, we're going half of that distance. Then we're taking the next step, and this distance is half of this half, which is 1 over 2 squared. Well, what is half of this distance? Well, this distance is 1/4, 1 over 2 squared. Half of that is 1 over 2 cubed. Similarly, half of that is 1 over 2 to the 4th, and so on and so forth. So therefore, we could write this as the sum of 1/2 to the n, starting at 1. It's an infinite geometric series. And because it's an infinite geometric series with r as a fraction, its sum is going to be a. A is the first term in the series. When I plug in 1, we get 1/2. Over 1 minus r is 1/2. We get 1/2 over 1/2, which is 1, which is what we would expect because we said this distance is 1 unit. Now, this is what you got to do to bring in a solid logical argument. Will we ever get there? Again, we really shouldn't in physics anyways. You can't talk about distance without talking about time. So we need to bring in time into this. So if I make my first jump, if this is the time it takes me to make that jump, I jump in 1/2 a second. Then I make this jump in 1/4 of a second. Then I make this jump in 1/8 of a second. And 1/16 of a second later, I make that jump. I'm adding up the time it takes. So if I do it that way, what I'm saying is, yeah, not only am I going to get there, but I'm going to get there in 1 second. Now let's say we look at it a little different. Let's say I'm a little tired. So the first step to go halfway, I do it in 1 second. The second jump, I just do in 1 second. The third jump is 1 second. Now we're adding 1 to all the way forever and ever. 1 plus 1 plus 1 plus 1 diverges to infinity. If you make your jump in this scenario, you're never going to get to the end because the time would blow up to infinity and you won't ever get there. It's just kind of an interesting little argument or application to using geometric series to argue Zeno's bisection paradox.